Hello, everyone. Welcome to the IEEE Communication Society podcast, episode number 22. This is Professor Aryan Kaushik, host of your series for the IEEE ComSoc of the podcast that we do. And today we are fortunate enough to have Dr. Alain Mourad with us. So he's a senior director at Interdigital and also the chair for ETSI Industry Specification Group on ISAC. So he was elected as the chair in 2023,
23.
and then now he's re-elected as in 2025 as chair, right? Congratulations,
Absolutely.
Alain, first
Yep.
of all.
Good morning, and thank you very much indeed.
Thank you for joining us. You're very much, welcome, to share your thoughts on the technology. So basically, I would like to start with some fundamentals, Ellen. So basically, what is this technology ISAC? So let's say some student is watching at home, right? So they want to see that, oh, I hear this term so many times now. What is it actually? So integration of sensing and communication, or some people call it unification of sensing and communication. So what exactly this technology is, Ellen?
Excellent. First of all, a very good morning to you and to the audience as well.
It's very early, by the way, in London right now.
And it's a bit chilly today, actually.
chilly,
It was, I think, first day, we had the frost this morning in London.
Yeah.
So thank you for having me indeed. Pleased to be with you. I think it has been long due.
My pleasure,
this conversation together.
Yes.
So finally we made it. We made it on time with that re-election as you just outlined. So to dive into the topic of ISAC, I mean, to put it simply, for the students who are familiar with communication, I mean, they should be familiar with communication, technology, where, an individual would give a call, for example, to another via the cellular network.
Yeah.
So here sensing is is a little bit different in the way that it's not about communication information from one end to another. It's about actually detecting, objects or environmental aspects that maybe lie, within a given environment of interest, if you like, whether for the end user or the operator or the business owner in a way.
Mm-hmm. And what can be, let's say, the applications? So let's say, to me, it appears that sensing is more of like enhanced capability to our communication equipments, or vice versa as well. The communication can be enabled for some sensing operations. So what kind of use cases or applications we are thinking?
Absolutely. I think there are plenty of these use cases, but
Right.
I think to set the tone right for sensing, it's best actually to take positioning
Right.
as a precursor, right? So obviously with positioning, right, you're not communicating anything, but you're actually trying to identify a given, what we call user equipment, a given device, right, in the network. So sensing takes it to that next level, right, with that ability that you can actually detect objects that may not be connected at all to the network.
Right.
Right. So you don't have actually to have a smartphone on you to be able actually to detect, that human being or the drone or whichever it is. Now, on the use cases, there are really so many use cases, right? And so if I were just to name a few, to be honest, I think you can think of, environment mapping, you can think of digital twinning, you can think of human, detection, intruder detection. You can think of, elderly people at home with some health monitoring to be done, to be conducted. Rescue, disaster relief, really a plethora of kind of use cases. And actually, the 3GPP, the third generation partnership project, in the context of their 5G advanced.
So in release 19, I remember they had
were-
introduced 32 industry
Exactly,
use cases. So
32.
these are the ones that you mentioned.
Absolutely. These were like the baseline ones. Now, on top of these, at ETSI, ISAC ISG, we added an additional 18 use cases,
Right.
totally differentiated, if you like, from these 32 use cases in the 3GPP, of course, with focus on 6G. And then following on that, the 3GPP in the framework of their 3GPP SA1 6G use cases, they also added an extra 20.
All right.
And many of these 20 that have been actually included into the 3GPP SA1 6G study, they come actually from the ETSI ISAC ISG as well.
Wow, nice.
Yes,
So you
absolutely.
kind of like feedback the sort of like advancements for further sort of technology like 6G and even beyond, perhaps.
Absolutely. And indeed, actually, it's the model of the ETSI ISAC ISG is a pre-standard group with the idea to be like 2 to 3 years ahead of, for example, 3GPP. So we were, of course, ahead when it came to the 6G ISAC use cases. So right on time, so that the members of the ETSI and the 3GPP members could take it to 3GPP at the right
and they
point
can
of time.
discuss
And
what to include
get
in
them
the standards.
adopted, and then formulate requirements as a result of these use cases. Yeah, but that's in a nutshell. It's really a wide range of use cases, right? Whether it is the environment, the factories, the drones, the UAVs, the human detection, you name it.
Very interesting. So let's say from 6G infrastructure point of view.
Yeah.
So what are the most important use cases, at least according to you, would make it for like 6G? So some things are that where we are very ambitious and we say, okay, we're gonna hit that spot, we're gonna do that, we're gonna do this, right? And some things are like more practical, more pragmatic in a way.
Absolutely.
So what kind of use cases, the important ones that can actually make up into our sort of 6G connectivity based on sensing and communication together? So what do you think?
Absolutely. Well, I mean, the 3GPP, as you know, is a bit pragmatic.
Yeah.
Kind of a group.
Yeah.
So they wouldn't go for the most ambitious
use cases. That's for academics, actually.
Exactly. So they already, as part of 5G Advanced, they already down selected a few use cases that they see actually low-hanging fruit, right, to set the framework anyway.
Right.
So you wouldn't be surprised to hear that the use case, primary use case, has been UAV detection.
Oh, right.
Drones detection. Of course, there are small additional use cases around human detection, but for pedestrians, for example. But that's about it.
But this is like a commercial application, or it sounds more on the military defense side of application?
I mean, it's both, but in principle, 3GPP aims at commercial, like civic kind of applications. It doesn't preclude that the defense sector could actually also leverage that. But yeah, think about UAV detection, from a civic standpoint.
And this can also lead to some other applications, actually, like in robotics, for example.
Absolutely.
Like with automated guided vehicles on point, right? Like you require some sensing to be performed.
Absolutely.
So I think you need like very high accuracy sensing capabilities. That's what I think for these operations to happen. So do you think that we can merge other different fields as well together, so it can be really like a multidisciplinary sort of thing with ISAC coming in picture?
Absolutely. And actually, it's worth taking a step back and look at how 3GPP started that integration of sensing and communication. It did not start it with enabling sensing capability using the radio waves of the cellular system. It started it with the large infrastructure of already incumbent and legacy sensors available, IoT sensors or cameras or you name it, right? That hold a significant amount of data that could be very relevant for the network to integrate. So that's how it started actually in the 3GPP 5G Advanced. So it was mostly about all these sensors, try to figure out a way to collect the data from these sensors into the cellular network, let's say the 5G network, so that you are able to process it, diffuse it, expose it, and do something with it, right? Then, thanks to the academia and the research community, there was this approach to say, you can also actually do sensing using the radio waves of, the base station itself or the user equipment itself. So the radio waves of the communication system. So not just, if you like, the cameras and so on, right? So that's why I always, when I discuss about ISAC, I always say, okay, there are at least two phases or two stages of ISAC. Stage one is really around the integration of all these sensing technologies or sensing devices, the data coming from these sensing devices into the network. So this is step number one, and this is what has already been actually really progressing pretty well with new functions in the core network of 3GPP. You'll be able to deploy this already actually using 5G eventually, right? And the second phase, which is more ambitious, and that's what I think you and I and other kind of researchers have been working on, is to say, okay, now what we call the 3GPP-based sensing, which is actually using the radio waves, that will actually lead to some form of integration or unification of the two, capabilities or functionalities in the same system, right? So this is, if you like, a second stage, right? Already with the first stage, you'll be able actually to appreciate the add value of sensing capability simply through the sheer data collection coming
Yeah.
out of the sensing technology already, the incumbent technology already available to us.
So I think, I mean, from our point of view, so when we started to work on it, so it was the idea of multifunctionality,
That's right.
that you want to have like multiple capabilities on your system, and you want to save, let's say, on the hardware
Yep.
and the spectral resources. You can use the
Absolutely.
same frequency for different operations. So in this case, let's say dual functional signal that you got with sensing and communication. So
Absolutely.
you can use the same frequency instead of using like different frequencies, and on the same hardware as well.
Mhm.
Or some people were saying, like at the beginning, like a coexistence scenario, like there can be a sensor in one corner of the room
Absolutely.
and maybe mobile equipment on the other side, and they kind of coordinate with each other.
Mhm.
So the idea was that they have some multifunctionality together and saving on the congested spectrum, or like saving on the hardware resources, like that. So that was like at least my understanding from the beginning.
Yeah.
But then with standards coming in and with pre-standards activities that you are chairing as well, so lots of other developments happened. So
course.
we became more crystal clear what we really want from this technology at the end of the day. Is that
Yeah,
right?
absolutely.
Yeah.
I think if you recall, 3-4 years ago at least, the research community did not call it ISAC.
Mm.
They used to refer to it as JSAC,
J is like the joint one,
Joint
yeah.
Sensing
But
and
it keeps evolving the term.
no,
Now I'm hearing unification is a better
yeah,
term
but
somehow.
it's pretty it's really an important actually observation here,
Yeah.
because for the research community who kind of pioneered, if you like, this concept of sensing and calm, they immediately actually shot for the most ambitious mode of really a joint sensing and calm,
Mm.
right? One system, one unified system, same spectrum, everything like unified.
Yeah.
But then the industry picked up interest,
Mm.
and they kind of shifted a little bit, or quite a bit, that concept of JSAC into what they call ISAC,
Mm.
which is integrated sensing and communication. And really the focus here is on the keyword integrated or integration, because you could have actually multiple levels of integration. The most ultimate integration level, right, would be the JSAC. You see, when
Right.
both capabilities are supported with the same hardware, the same spectrum, the same resources, they are, simultaneously, available, in the network. So this is, if you like, the most advanced and most ambitious
Yeah.
kind of mode of integration.
Yeah.
Now, if you take it to the other extreme, actually, then you can think of, two systems, completely different systems, including, the legacy, as I said earlier, the legacy sensing technology, IoT, and so on,
Yeah.
right? These systems, you just like them to kind of coexist, right? And if you can find a way to maybe leverage the data, right, both way, to improve on the services both way, then you can achieve some benefits.
Right.
But this is, if you like, the most extreme, level of loose integration
Yeah. Yeah. Yeah.
compared to the most extreme case of advanced integration, which
Exactly.
is a unified.
Yeah.
And then, of course, in that spectrum, there are multiple,
Multiple
intermediary.
things within.
Yeah,
Yeah.
absolutely, multiple things.
And also, Alan, I think they mentioned, let's say, in the 3GPP standards release 19, when ISAC was actually introduced as ISAC, let's say, not really JSAC. So there we had something at the very beginning, like communication assisted sensing or sensing assisted communication. So we were saying that we will work around these. So we will not be so ambitious. Let's pick one operation as the main operation. Other can be like a complementary function to the main operation.
Yeah.
So what was the idea behind that, and what kind of applications or use cases we were targeting, while keeping in mind that we will start with something simple, let's say something achievable?
Yeah,
So
absolutely.
what was the idea behind that?
Yeah, I mean, these remain to be of interest. And I think we should distinguish, sensing aided comm and communication aided sensing from what is typically known as use cases that we discussed earlier. Because
Yes.
what we discussed earlier as use cases, so these are from the end user standpoint. So here, when we talk sensing aided comm and comm aided sensing, we rather talk about the functionality in the network, right? The operation of the network, right?
Mm.
So how can sensing actually help communication, assuming that you have these two capabilities into the network? Of course, the sensing data can be used by the network to improve on the behavior of the network. For example, if you may be able to detect certain blockage through sensing, right? That information in real time fed back to the network can help the network, if you like, steer the beams maybe to another area, or kind of reconfigure, the run resources in a way that, you can actually get, increased coverage or serve other nodes. If, for example, there is no point, continuing to kind of cover with a high throughput kind of configuration, if you like, towards a given node that may be obstructed, for example. So this is like a small example of how you can actually leverage the sensing data towards the communication. Of course, you can also leverage it in a way to say, okay, that sensing data may be of interest also to the application or the service that's actually using the network. And if that sensing data actually can help that application, optimize or adapt its behavior, then it might actually consume less resources from the network. So if you like, the end-to-end delivery of that service via the network
Yeah.
will be much more optimal thanks to that sensing data.
Yeah,
Right? Think
exactly.
about it in this way. Now, of course, if you take it the other way around, how communication can aid sensing, right? I mean, the simple thing to take. I mean, first of all, if you can actually do sensing via the 3GPP signal, as we discussed a bit earlier, you are already actually adding an additional source of sensing to the already existing legacy technology of sensors. So that additional source of sensing will give you actually the ability to fuse multiple sensing sources together,
Yeah.
especially trusted sources like the 3GPP based one or the cellular network kind of based one, so that you actually improve the accuracy of your sensing technology. But things actually don't stop here. So if you just, of course, I mean, we have to touch upon AI, but and
Yeah.
AI is going to be in the network, and it's already in the network
Yeah.
anyway, right? So that large volume of data that's available via sensing and collected by the network, I mean, this is a perfect actually data set to do training for models, to use it for kind of AI applications in the com system. So that's why actually today people also don't talk only about sensing aided com and com aided sensing. They also say, okay, sensing aided AI and also AI aided sensing, because of course you also need kind of AI in a way, to kind of help with the detection of objects, classification of objects,
Estimations, a
imagery,
lot of estimations.
estimation.
Yeah.
So the three fields, if you like, they come pretty much nicely together, if you like, into one frame.
So we might hear a new term with the integration of sensing AI and comms.
It's already there.
Right.
Absolutely. Yeah. I mean, the good thing, as you know, if we make a reference to that wheel diagram from IMT 2030,
yeah.
right? So they kind of put actually integrated sensing and comm on one end of that six vertices,
hexagonal thing,
the
yeah.
hexagon thing. And then right across, you have
Is
the
AI
integrated
and
AI
comms.
and comm, but there is actually these two should be looked at actually also together. So it's really an integrated
It's like
sensing
an
and
interplay of
comm
these.
and AI absolutely together. Indeed.
Interesting. So I think it also has like good applications in some sort of like autonomous driving. I think it's a perfect example
Indeed.
of combining all these things together. You need your AI algorithms to kind of train the sort of driverless car in a way, is that that these are the patterns, these are the sort of trends. And at the same time, you need to sense where are the pedestrians, vehicles, or any other traffic light, or maybe if you have a race on a building or something, like an intelligent meta surface. I mean, that's a different topic anyway.
Right, exactly.
But I think so you can sense these things as well. At the same time, you can communicate the signal. Let's say if you need some sort of remote controlling or monitoring the sort of driverless car, so you can use 6G infrastructure, the communication signal. So it might work like very well, I think, in vehicular scenarios quite a bit. And also for NTN actually, because you mentioned about the UAVs, the detection and all, right?
Absolutely.
So I think there for the path planning or sort of trajectory optimization, or especially in the cases of search and rescue, mission critical services,
Absolutely.
it'd be very important to have like very high accuracy sensing, and with some usage of AI as well, that your things are faster, your estimations are highly accurate in a way, right?
Absolutely.
And also you are able to communicate with the any stuck objects or any
Mhm.
vehicles or any sort of that thing or any humans, when we talk about like sensing around
Absolutely.
humans
Yeah.
in the disaster affected area.
Absolutely.
What
I
do you
think
think?
this is a great point actually you make. Especially, I would like to comment on that satellite component.
Mm,
Right. I mean, for sensing to work, you need precise positioning.
mm,
Right. So
that's it.
this is important.
Yeah.
Right. And of course, satellite helps a lot with the positioning accuracy.
Mm,
Right. So localization anyway. But it doesn't actually stop at this. So one key point actually how, for example, the cellular network-based sensing, what we refer to in the industry as 3GPP-based sensing anyway. So a major add value of the, being able to do sensing using the radio waves of the cellular network
mm,
is really the scale compared to the legacy sensors available today. Because most of the legacy sensors available today, they are proximity sensors. They are
mm,
short range kind of sensors.
mm.
Whether they are the sensors in the car or the sensors, with cameras, they have a certain field of, range,
Field of view, let's
field of
say.
view, but
Yeah.
also range as well, right?
Mm,
Also radars themselves, so they have certain range, right? So really what you get actually that significant add value by doing that sensing via the radio waves of the cellular network is the scale and the wider range, thanks to the frequencies we use, of course, sub 6 gigahertz and so on. Now, if you add on top of that the satellite,
mm,
then you can appreciate actually how much wider kind of scale you can achieve, in terms of sensing range and sensing coverage, right?
exactly.
So it is really around, if you like, the satellite contribution is through the positioning contribution of satellite to the positioning accuracy that's needed for sensing, but it's also the ability to cover a wide area,
Mm,
through the satellite combined, of course, with the terrestrial. Right, so both I think come play nicely together. So it's not.
mm,
So when we think about the satellite contribution to sensing, it's not. It shouldn't be perceived exclusively from the point of view of the use case of UAV, the flying UAVs. I
mm.
mean, even for ground-based kind of sensing use cases, satellite can help, especially as you pointed out, in these wider areas or remote areas and
Rural
these
areas, remote,
rural
yeah,
areas and so on.
marine areas,
Very
and
absolutely,
and so on.
exactly.
But I think satellites, they have like a bit of issue with the, let's say, the heavy payload that we talk about.
Yeah,
And now we are talking about AI and everything to kind of plug in into
right.
the satellite based connectivity.
Hmm.
So do you think, does it make sense to add additional things like with sensing on board, let's say?
Yeah,
I mean, whether it can be on the satellite itself or maybe on the ground, and they can kind of like coordinate in a way, satellite with the ground
yeah.
network. So do you think that it adds on more complexity than actually making our lives easier in a way? Or is the other way around, that is actually is, I mean, the benefits are, of manifold compared to, let's say, the complexity. So
Mm.
is there a trade-off, or is there like
Yeah,
one better than the other? What do you think?
I would say it's the latter actually,
Mm,
because at the end of the day, with sensing, you're not actually transmitting significant, data packets and things like that. So at most, you might actually need just a pilot signal, and it's that pilot signal actually which you might already have in your own communication modem on the satellite. You don't
mm,
need anything extra,
yeah.
and so actually you only focus on the reflections of that signal from the objects, and then do certain
But that
processing.
needs a bit of processing because you
Right,
get the
but
echo waveform back from the,
exactly, but
target or like whatever object you want to detect. So that requires a bit of the complexity, no?
that's a great point. But I
Mm,
mean, we don't have to kind of only think about the monostatic mode. And
mm,
monostatic refers to the same node being the transmitter and the receiver,
mm.
right? So you
So
can
it can be
actually
bistatic
you can
and
think of biostatic,
yeah.
that the signal eventually could be transmitted without any add on, if you like, to the satellite,
Mm,
but then the reflections from that signal when it hits a target object could be actually measured via ground nodes,
mm,
right? Whether they are base stations or they could be even user equipment, devices. So that's why I think we shouldn't just think about sensing when we are integrating sensing that we are adding significant hardware, you know, uh, to the modem, to the transmitter, and so on.
So with the basic available architecture, we can actually enable
Already,
already.
absolutely.
I mean,
Yeah.
yeah. I mean, of course, I think it's quite useful. But it leads to me another question, Alan.
Mhm.
So you might appreciate that there are some societal
Of
concerns
course.
related to when you talk about how
Mhm.
much of you, I mean, how much of the things you can actually sense, right? So especially when you're talking about the wide range
Mhm.
using satellite.
Yeah.
So I should not be sensing everything that comes my way, right? So a satellite has a wider coverage in a way, so it can cover, let's say, London and maybe Surrey as well, for example,
Mhm.
right? So in these cases, you have different compliance issues for Surrey and London, perhaps, right?
Mhm. Mhm.
So how would you make sure is that the privacy that we are talking about, or the security concerns that we are talking about, so how are these being addressed in terms of like the pre-standards and standards, and also let's say some sort of industry development? And one more question related
Yeah.
to that
Okay.
just coming to my mind is which one you think is more important, security, privacy, or privacy? Like which of the, I mean, either is more important to be addressed first during 6G, or they are both having the same weightage that we're talking about. What do you think?
Yeah, I'm glad you mentioned or you touched on security and privacy. Right. We also kind of put in the same bucket also trustworthiness as well
Yeah.
and resilience.
Mm.
Right. I mean, this topic, was acknowledged as being very, very important
Mm.
if we were at all to deploy that technology in telco networks. So from the outset, for example, of the ETSI ISAC IG in what we call the first release, the one that we started in 2023, we created a work item dedicated to security, privacy, and trustworthiness.
Mm.
And this work item actually focused on what we call key issues. So, what are the key issues for the network, for the 6G system,
Yeah.
that require solutions to support or meet the requirements of security, privacy, and trustworthiness, right? And I think for the audience, we can say that we are almost ready with the publication or the release of what we call the group report
Mm.
004 from that work item.
And this can be found online.
Not yet, but
Mm.
it will be actually released with a press release from Etsy, most likely in the Q1 2026.
Mm.
Given the importance of this topic, in that second release of the Etsy ISAC ISG that we started actually on Monday, yesterday, 17th of November,
Mm.
2025, for 2 more years.
Mm.
All the industry active in this group, they all, expressed the need or the interest to continue working on the topic of security, privacy, trustworthiness, and resilience, given the importance of that topic. Now, when we talk about these, what do they mean in practice, right? So, privacy, I would say, comes first,
Mm.
right? I think more than security, because here in security, we are not kind of transmitting here, data packets are going to be actually, or messages are going to be detected,
Mm.
right? So, but privacy is, if you like, the utmost concern, especially with the GDPR. So, how do you make sure actually that the data that you are obtaining from sensed objects, especially if these objects are like a human being or certain, type of objects, for business use or government use or you name it, right?
Exactly. Yeah.
So how do we comply, if you like, with the regulation around the privacy? So this is, if you like, topic number one.
Mm.
Then if you move to security, it's more actually around the protection. I mean,
Mm.
security in a way slash also resilience. It's how do I actually ensure that the signal that I'm transmitting for sensing, right, doesn't actually get picked up by an eavesdropper.
Mm.
Well, it's not really an eavesdropper because typically eavesdropper is in the context of communication.
Yeah.
But here, think of an equivalent of the eavesdropper, someone who's able actually to observe the signals that are bouncing off the target object and being able to also make measurements and get the characteristics of that object. So if you like, a node who's not intended to make the sensing, right, or evolve in the sensing, but then takes part of that sensing to obtain certain characteristics.
Mm.
So there is this angle that we kind of focus on how can you actually protect the signal itself in a way that it cannot, any kind of bouncing from the target object, you make it very difficult for an unintended, if you like, receiver to derive certain characteristics around the object. But it doesn't also stop here, what we refer to as security. There's also the data itself. I mean, the protection of the data, that you collect, whether they are the measurement data sent to the processing node or the transmission of the processed actually data for sensing towards an application or towards, a network function. So here you also need to put in place some security mechanisms, no doubt about it. Then, comes trustworthiness. It's really how much actually trust you give to the sensing data. How valid it is, how verifiable it is, the integrity of the data, especially if you were also actually to kind of fuse the data with other sources, external sources of sensing, whether they are Wi-Fi sensors or they are IoT sensors or camera sensors, right? So you need also to be able, actually, especially for telcos, right, to have a certain integrity of that data, right, and certain validation of that data before you can actually use it yourself or you can expose it to applications, or services on top of your network. So it's really this whole combined, framework of privacy, security, trustworthiness, and resilience that really require, significant development. And as I said earlier, in that second release of HCI ISAC, the focus is going to be on the solutions. Because in the first release, the first 2 years, we worked on what are the key issues and then the requirements actually stemming from these key issues.
And defining them first.
Exactly.
Yeah.
And now going forward in the next couple of years, the focus of the industry and the academia will be on bringing solutions to address the requirements actually of these key issues. Now, of course, in tandem, the 3GPP is looking at, what needs to be enabled on their end as well, especially the group, I think, 3GPP SA3, which actually deals with security. So they are also looking into, what needs to be added in terms of security and privacy mechanisms into the 5G, architecture, but also importantly, as a study now, in the 6G architecture as well.
One as well.
Absolutely,
Yeah. I think it's quite interesting. Do you think of any other sort of constraints that we have while implementing this integration of sensing and communication? So other than security, privacy, resilience, and trustworthiness, do you think of any like system level issues that we may have problems while integrating these operations together? So people were, we were talking about, let's say in security privacy aspect, the interference that comes from multiple users, multiple targets when you have massive connectivity.
Yeah.
But let's say it can also happen that you have intra-operation interference, that you have sensing and communication data overlapping with each other, and basically the processor is not able to detect or like predict like what it actually is. So you have some interference, one entry overlapping on the other, right? So do you think there are any other constraints like that, or some hardware constraints, or any other architecture constraints that we think of, some, any sort of like issues that we can face,
Absolutely.
you think?
Well, before maybe we touch on constraints, I think because you started the question saying, what other kind of dimensions we should also pay attention to on the system level for that integration. We already covered security, privacy, trustworthiness, and resilience. One major aspect that we didn't touch upon is energy consumption and energy efficiency, and what's actually the energy footprint for that integration of sensing with COM. As you appreciate, the energy metric is a major metric.
I think it's one of the most important, actually.
For the total cost of ownership of the network.
We missed a lot in 5G.
Exactly.
For energy efficiency, we were too much, concentrated on capacity. Sort of having a lot of data kind of like squeezing in, but energy was missed out. But I'm glad that in 3GPP release 19 and 20 and so on, energy efficiency is also being considered as one of the important key performance metrics or indicators, let's say.
Yeah, absolutely. And that's actually taken from the 6G system standpoint. But here I just wanted to kind of hammer down the point that, there is an energy cost for integrating sensing with COM.
True.
And depending how you do that integration, that energy footprint of sensing integration with COM is going to be different, right? So what are the solutions that are needed to be put in place so that actually that integration is green or is energy efficient? So this is also an important topic that need to be addressed, right? And it's not, if you like, to do with the radio, the way you do the radio, the integration of the radio transmitter and receiver.
Mm.
It's also, it's really an end-to-end system aspect, because it's also where you do the processing of the data. Where do you kind of send that data, where you keep it, where you process it,
Mm.
where you pre-process it or post-process it, how do you expose it, right? There is an energy,
So for the
cost,
data volume handling,
the
you
data
require the
volume
energy.
handling,
Yeah. Mm.
really, this is a big aspect. And of course, in the same way, if you like, as telcos are sensitive to how much of the spectrum they need to kind of allocate or to give, if you like, for, or to free in a way,
Mm.
to enable the sensing capability. I mean, ideally for them, they don't want to free anything. They would like actually the sensing capability to come for free from a spectrum usage standpoint.
Right.
That's what they say, right? But and so
Mm.
in the same way, I think they also are paying attention to, okay, what is it? What does it mean? That sensing capability in terms of extra, energy cost for the operator, right? So this is key.
Mm.
Especially, it should be put in the context of what we discussed earlier, that phase one of the sensing, what I call this, phase one or stage one, which is, already with the incumbent sensing technology, you may be able actually to enable that
Mm.
capability.
Mm.
So without, if you like, the network-based sensing, right? So then the question becomes, okay, if you already have these incumbent technology, right, they're consuming what they are consuming as power,
Yeah.
and you're already making a good use of it for certain applications, you moving up or considering to the network-based sensing, and you eventually spending some extra energy on that, will it be actually worth it,
Mm.
right? Will the add value from enabling that sensing for these use cases from that additional source of sensing, which is the network,
Yeah.
right? Will it be worth, if you like, the energy cost that it implies, right?
Mm.
Again, there are no answers actually to this yet. So that's why I say this topic of uh, energy footprint, energy efficiency, taken end to end, right, is a major system aspect that need to be actually tackled. No doubt
Mm.
about it. Now, I think the second part of your question was more around, I think constraints and interference. And of course, I mean, these play a major role, whether it is interference from within the sensing
Yeah.
itself,
Yeah.
because if we take, for example, the monostatic, right, where the same node, is transmitting and receiving, I mean, even there, actually, you have interference
In
between the
itself, yeah.
transmit and the receive, right?
Mm.
So how do you go about the duplexing? How do you ensure that there is a proper isolation, the cost of that isolation in the same node, right? But then, imagine that you go even to that other extreme and you're actually doing the sensing collaboratively or cooperatively between multiple nodes, and eventually some of these nodes being actually smartphones,
Mm.
UEs, so which means they are on the move,
Mm.
right? So that complicates a lot,
Mm.
the landscape of the
True.
interference and errors and issues, and at the
So
end,
lots of things are required to solve these.
absolutely,
Yeah.
absolutely. So I
Mm.
think there are so many things that need to be actually paid attention to so that you can actually derive a proper value
Mm.
out of that integration.
Yeah, but we have existing technologies for many of these. But I mean, in context of like sensing and comes together, you have some changes in the sort of fundamental problems.
Of course.
But I mean, you will not come up with like completely new solutions. You can pick up something from, let's say, a decade ago, two decades ago. But still, you need to make it work for a joint system. Right,
Yeah,
when you were
absolutely.
talking about, let's say, the spectrum
Yeah,
part, right?
right,
So we are moving towards centimeter wave, let's say,
right.
for the 6G, right? As far as 6G is
Hmm.
concerned,
Hmm.
and maybe sub-terahertz in some geographical locations, right?
Right.
So we need to make sure that ISAC is deployable at these frequencies. So we are talking about using it at microwave frequencies,
Hmm.
but at the same time at 7 to 8 to 12 gigahertz sort of frequencies, we want to utilize sensing and comms together for that as well. So
Good.
it may pose few more challenges, perhaps, even though these frequencies are not so different from the sort of sub 6 gigahertz frequencies, but still, there may be some effects that we may not, be fully aware of when we actually implement the thing and operators are providing that, right?
Absolutely. No, absolutely. You're absolutely right. And, you know, without, if you like, going above 100 gigahertz. So
Yeah.
let's leave the sub-terahertz for
Yeah.
the academic colleagues, to continue work
Yeah.
on that. If we just actually even limit ourselves within the first 100 gigahertz,
Mm.
which was, if you like, the cap for 5G as
Mm.
an operational range and spectrum, right? Even there, I mean, there are already actually, as you pointed out, I mean, the propagation mechanisms are well understood in these frequencies, whether they are actually from the communication
Mm.
systems already available, or importantly, whether they are actually from the radar.
Radar side as well.
Yeah,
Mm.
because we have radar, working in all these frequency ranges up to the 100 gig and even more,
Mm.
right? So the propagation, if you like, mechanisms are really well understood anyway.
Mm.
It's just that integration aspect of it, of the sensing and comm at these frequencies, that need to be paid attention to,
Mm.
right? So especially, regarding the objects, I mean, for each use case to be enabled, the objects, the specs of the objects matter, right? So all these kind of things need to be baked into, if you like, that sensing framework, the integration sensing framework with comm, right? Yeah.
Definitely, Alan. So brilliant. I mean, you mentioned actually lots of stuff. We discussed lots of things. So I think it was very interesting to
Sure.
chat with you. Any final thoughts you would like to share, Alan, before we conclude the podcast? Do you have any like future things that you want to talk about, or something that is a secret that is just between us but will be watched by everybody now?
All right. Yeah. Obviously, we'll not touch upon any secret of. Thank you for having me. It was a great discussion. I mean, of course, the time, run fast here.
Yeah.
So perhaps, to conclude with is to say that really the roadmap of ISAC is going to be, taking quite a few releases, as we say, both in 3GPP and NETSI, right? So it's not, if you like, going to be a job done in the next couple of years. So the research community, I think, should continue to work on it. The standard and the industry community will continue to work on it. And if I just actually wear my hat as ETSI ISAC ISG chair for the second term, I would like to say stay tuned. There is an important milestone coming up, which is our next plenary meeting in London, 16, 17, 18 December. Where the ETSI ISAC IG members, about 110 members, companies and academia and government, they will be actually approving what we call the work program of the second release. So this will be the work items, right, that will be pursued by this group for the next 2 years, so 2026, 2027. And we're already actually seeing, some consensus forming. I think I already mentioned one around the security, privacy, trustworthiness, and
Yes.
resilience, but there is more to
A
come.
lot more coming.
So
Yeah.
please stay tuned. I think most likely there's going to be a press release from Etsy on that during that week. So stay tuned and please come and contribute to Etsy ISAC IG.
Definitely, Alan. Thank you so much. We probably need to do another podcast then, catching up on what's happening
Absolutely.
with all these meetings and so on. So I think it
Mm.
looks fascinating to me as well as a technology. I remember right after my PhD, I had started also working on ISAC technology and energy efficient aspects and many other things,
Yeah.
and I just continued with the sort of like developments and so on. But thank you so much, Alan, for joining us today. It was really
Thank
a
you for
pleasure
having me.
to talk with you, and hopefully we will catch up again very soon, and then we'll discuss more on ISAC and where it is heading and the timeline and so on. So we will catch up on that as well. Thank you so much,
All
Alan.
right. Yep. Thank you for having me.
Yeah.
Yeah. Appreciate it.